start talking about y double prime, y triple prime, the fourth derivative, okay, you could keep going all the way to what we have called the nth derivative. So we can, you have a first derivative, you have a second derivative. So this is known as your first what? Derivative. So y double prime now will be the what? The second what? Derivative. Second derivative. So you might say, what's the definition of the second derivative? Okay. So y double prime is defined to be the derivative with respect to x of the first derivative. And of course, there's a lot of different notations. You might have d squared y over dx squared. That's also a second derivative. So you're looking at, let's do it this way. Let's say this is the definition of the second what? Derivative. Okay? And this is a different notation you can see. If they give you, if you guys recall, say if y is f of x, and we know dy dx, bless you, and you use this operator notation, well, this is f prime x, okay? So we can just say, here's some more notation here, the different notation. Y prime or dy dx is f prime x, okay? So we know that, and then you might say, well, what about that second derivative? Well, the second derivative can be thought of again in terms of this first derivative is f what now? Double prime. So here's your second derivative. Okay, and now you might say, well, what happens with the third derivative? Well, do it again. And so on. The third derivative is the derivative of the second derivative. If they give you operator notation, you have the second derivative. Well, that's going to be now 3 dash line. That's third derivative. And then we do have the dy, the d cubed y dx cubed notation as well. So this is your, I should say your third derivative definition. So you could keep going, fourth derivative, and so on. So you can't start with a third derivative. You have to get the first before you get the second, before you get the third, before you get the fourth. Okay? So starting with a very simple example here, right? Say here's y, 3x to the fourth, minus 12x cubed, plus 6x squared, okay? Here's a function, and they're going to say, what is the second derivative? Okay? And you might say, well, how do I get this? How do I get the second derivative if I don't even know the first derivative? Because the definition of that second derivative, right, is to do what? To differentiate the first derivative. So what do you think we have to do? We have to differentiate the what? First derivative. Okay. So I need that first derivative. Y prime will be, I'll use my operator what? Notation. And I pull out my constant. Differentiate x to the fourth. 12. Differentiate x cubed. 6. Differentiate x squared. Okay. Now, what do you guys think I do for the derivative of x to the fourth? What's that derivative? Isn't that 4x cubed? Don't we use power rule here? What about x cubed? Isn't that what? Okay, and then x squared, that's what? 2x. So don't forget, this is going to be 3 times 4x cubed minus 12 times 3x squared plus 6 times 2x. So that first derivative becomes 12x cubed minus 36x squared plus 12x. So this is not the second derivative. This is your what? First derivative. So, okay, they want us to get the second derivative. Okay. Second derivative is when we differentiate the first. So use your properties and let's see what we get now. What's the derivative of x cubed? 3x squared. What's the derivative of x squared? And the derivative of x. Okay, so let's put it all together here. That second derivative will be 36x squared minus 72x plus what? Plus 12. Okay, you guys okay with that? Now, how did we get all those answers? 12 times 3, negative 36 times 2, 12 times 1, and there you go. Easy peasy what? Lemon squeezy? And note, they didn't ask you, but what if they wanted the third derivative? Okay, how do you guys get that third derivative? Differentiate the what? Second derivative. 36x squared minus what? 72x plus 12 here. So use your properties again. Pull out your constants. What's the derivative of x squared? 2x. Derivative of x. And the derivative of a constant. So, again, if they asked you, that third derivative will be 36 times 2 is what? 72x minus 72 times 1, which would be what? 72. So, ladies and gentlemen, there you go. Easy peasy what? Lemon squeezy. You're just taking the derivative over and over again, and that's called a higher order derivative. Now, there's really physical applications to this, but first you have to handle the mechanics. Right? You guys know what I'm saying? And then what if they gave you? Let's change that to 3 sine x. And they want the second derivative here. So what's the first derivative going to be? Pull out your constant. Okay, what's the derivative of sine? You might say, uh-oh, what do I use? Anybody want to tell me? This is chain rule. Is that true? Don't forget your chain. And the derivative of x squared is what? 2x. So your first derivative now is, let's put it all together. Let's see what we have. We have the constant 3 cosine x squared. We got 2x. So all together now, looks like it's going to be what? 6x cosine x squared. Now, that's not the second derivative. How do I get the second derivative now? Differentiate again. In other words, the second derivative is the derivative of the first derivative, which is 6x cosine x squared. It's the derivative of the first derivative. And then now you might even say, well, what do you do here? What do you guys think you do? You're going to use what here? Product rule? How do you guys know you have a product? Yeah. So I'm going to do the product rule here again and pull that out. 6x times the derivative of what? Cosine x squared plus cosine x squared times the derivative of 6x, and I'm running out of space, so. So I'm going to do the easy one. What's the derivative of 6x? Isn't that just 6? Okay, and then maybe you want a visualization. Let's take a step back. Some people say, can you give me the colors here for what you're doing? Well, that's product rule. Is that true? But what you want to remember, I think, you're going to have to use what here? What's going on there? Chain rule. So what's chain rule for cosine? What's the derivative of cosine? It's negative sine x squared don't forget the chain, the derivative of x squared, which will give you 2x. All right. So, ladies and gentlemen, the second derivative now, let's take the 6x, let's take these values here. What do you guys get here? 6x times a negative sine x squared times 2. Isn't that going to be negative what? 12x squared what? Sine x squared. Plus what? 6 cosine what? X squared. And there you go, ladies and gentlemen. Is that easy peasy lemon squeezy? Wow. You just follow your what? I mean, if you're first learning power rule this weekend, I mean, should I dare say it? I mean, if you did that to yourself, I would say I feel really bad for you, because as you guys can see, as you're piecing this together, you can kind of do it in your sleep, so long as you what? Have kept up with what you're supposed to do. If you're going to do it at the last second, then it becomes a lot more, let's use the word challenging, because it's true. It'll be a lot more what? Challenging. Is that true? I've been teaching this course for I don't want to say how long. So I have seen through the years various things. Okay, how about this? We'll try this one. Okay, they want the first and the what? Second derivative. Okay, let's give you guys the first derivative again. And notice this, x what? Sine x. Okay, what rule do you guys use here for this? Product rule, is that true? Okay, so you're going to pull out your what? Pull out the x, and you differentiate what? Sine, and then that's plus sine, and then you differentiate the what? The x variable. Okay, what's the derivative of sine? Cosine. What's the derivative of x? Is that 1? Okay, so this would be x cosine x plus what? Sine x. That's your first derivative. Now, what's the second derivative going to be? Okay, differentiate what? X cosine x plus what? Sine x. So, in this situation, don't forget you have the derivative of a what? Of a sum. Is that true? The derivative of a sum will be sum of what? Derivatives. So what do you do right here? Product what? What's the derivative of sine? Okay. So by product rule, x, differentiate what again? Cosine, pull out your cosine, and then you differentiate what? X. So what's the derivative of cosine? negative sign. What's the derivative of x? 1. So it looks like this is negative x sine x plus what? Cosine x. There you go. Easy peasy. What? Lemon squeezy. Another example. We have to give you the square root of x, take the square root of x squared plus 1. And they want the first two what? Derivatives. Okay. So the first derivative will be, take the x squared plus 1 to the what? To the 1/2 power. What do you guys have to do with this now? Do you guys know? Yeah, power rule. It's actually power rule with chain rule. Is that true? Is that power rule with chain rule? Now, if you say, does the book have that? I think the book uses u. Is that right? And u, don't forget u prime here. I use the triangles. So this would be 1/2 x squared plus 1, 1/2 minus 1 times the derivative of what? X squared plus 1. Okay. Now, what's the derivative of x squared plus 1? That's going to be a what? 2x. So you get 1/2 x squared plus 1 to the minus 1/2 times 2x. What happens with these 2's? Right? So y prime will become x over the square root of what? X squared plus 1. Yeah. I don't know. Did I make a mistake?
Next to the way you differentiated x, there's 2 cosine.
Oh, okay.
Yeah.
I see your point. Thank you so much. Thank you. So you're going to put what here? 2. Good job. Thank you so much. All right, what about this one? How do we get the second derivative now? Yes, quotient rule. Is that true? So I take this square root of x squared plus 1 and I square it. I bring it up here and then differentiate what? X minus x, derivative of that square root here. Okay? And this is 1. Is that true? And then the square root of, well, the derivative of this derivative right here. Notice this. Okay? Notice you already actually have that. I mean, you did it already. That's x over what? Square root of x squared plus 1. See what you did above. Okay, let's put this all together now. The second derivative will be square root of x squared plus 1 minus x squared over square root of x squared plus 1. Everything over just the x squared plus 1 here. Okay, because the denominator, you have that radical to the second power. And so now you might say, what do I do here? Square root, right? You'll have x squared plus 1 over square root x squared plus 1 minus the what? X squared over square root of x squared plus 1, everything over x squared plus 1. And so the numerator now becomes just what? 1 over square root x squared plus 1. Don't forget you're dividing by what? And so your final answer will be 1 over x squared plus 1 square root x squared plus 1. You can leave it like that. Okay, you can leave it like that. Double check. And I know that's going to be 3 halves. If you said, can I leave that as 3 halves? You can, but this is what it is as well. Okay, you guys okay with that? Now, we just started this section, so I'll put some homework there for you, but I hate to say, I'm going to break your guys' heart. I have a meeting at 9:30, and I have to let you guys go early today. Yeah, I know. It's heartbreaking. You guys are, I know you're probably heartbroken, but I do have to get at this meeting at 9:30, so I'll put your homework in Canvas. It's just starting 3.8, higher order. And then that's that. All right? So I did put the study guide in the what? In Canvas, modules under study guide. It makes some sense. And I'll see you guys tomorrow.